All right, let's see how far that takes us. So I wanted to talk about kind of the first theoretical subject today about metaprogramming, but to make it not so theoretical, just use Ruby as a guide. So meta is just a general term that you use for words that talk about something at a higher level, like metadata is data about the data. Metaprogramming is to write programs that modify programs in some way, and it could mean in just about any way you want it to mean, but generally it's considered a program that kind of operates on itself. And this is something that has been around for a long time, as you'll see when we get into Lisp and scheme programming. It's oftentimes easy to write programs that generate other programs or that modify other programs. And the standard saying is that I'd rather write a program that writes a program than write a program. And so that's obviously how we all feel about this. All right, so we need to get into a few preliminaries of what it is that Ruby does to make some metaprogramming possible. So first of all, unlike other languages such as Java, in Ruby, when you build a class, when you have the class command, then stuff happens, and what happens inside here, these are commands to modify the class. So over here, but you can put in any commands you want. So what I'm doing over here is I'm making a class test, and now I'm putting in these instructions. I say print string hello, print self.class. So over here, I'm now as soon as this thing closes, as soon as the end closes, the code starts running. So in this case here, it prints hello. Then it prints self, that's the same thing as this. And now in this case, it says I'm test. What kind of test is it? It's an object that refers to itself as test, whose class is the class. So as this code runs, self is set to the class, the class that directs the behavior of all classes. So my point is anything that is inside these lines between the class and the end gets run as regular old code when you define your classes. So anything in here is regular old code, and it generally is going to be code that modifies the class in some way. In 2 lectures ago, you saw the thing where we added attributes to the class. And so that code simply runs. The class starts out with no attributes. That attribute adder code runs, and afterwards the class has a few attributes. So the next thing that we've seen is that you can add methods to individual objects. Actually, no, we haven't seen that. That's new. But so here's how you do it. So here I have an object that is X. It's a string object, and I just initialize it with C++. And now I can add a method to this individual object, x.toS. Is a method that operates on X, and so to convert the string to another string, I'll translate it as Ruby minus equal for whatever reason. So now when I call x.toS, then it no longer gives me C++ as it normally would have done, but it gives me this other return value. So I can modify individual instances in any way that I want. And that works for all classes except for technical reasons, these very primitive classes, numbers, booleans, and symbols. Now comes the first really interesting one, and that is method missing. So when I call a method on an object, then Ruby will look through all of the methods that object is capable of handling. Yeah, you have a question?
In the previous slide, define x.to_s giving an error. Yeah, it's only DEF.
Oh, I'm sorry. Okay, thanks. All right, I'll fix that later. DEF. Okay. So when you have an object and you hit it with a method, then if that method doesn't exist, then it'll say, well, that method doesn't exist. But before doing that, there's one last chance. It'll try to invoke the method called method missing. So over here, where I'm going to define method missing. And this particular method missing here, what does it get? It gets the name of the method that one tried to call and that wasn't there. And then it'll pass the arguments. And this particular thing here does something with imitating Roman numbers. So when I say Roman dot LXXIV, then it comes back with the answer 74. And so what's remarkable is that that method, that LXXIV, I've never defined that method. In fact, this object has no defined methods at all. But when it gets into the method missing trap, then one interprets to crunch down what these Roman numbers are. I copied this code. I have no idea why it is. It's just Roman numbers. So it'll work with any Roman numbers that work with this particular scheme. If you were to call Roman.foo, then what would happen? It'll probably return 0, right? Because it'll make some substitutions in here and it'll count a bunch of stuff and it'll probably just not do anything useful. Now, of course, I could do a different kind of method missing. I could check in method missing, is the name this, is it that, and otherwise I could call super.method missing and then it would generate the usual error message. So in the class object, method missing is defined to complain that this method is indeed missing. But I can intercept myself in there, and I can say, well, wait a minute, these methods are not actually missing. So you can, with method missing, you have an incredible flexibility. You can have any object behavior change to do really anything you want, because you simply catch the method invocation in method missing, and then you do whatever it is that you want to do. So the danger is, of course, it is not very easy to program with that. So people only want to use it when you're in a situation when you have a very large kind of open-ended collection of methods that you want to implement. One example in practice is the XML builder that Ruby has. So here's an example where you can build any old XML with this, not just HTML. So here's the builder XB, and then I call the method hello, and it has as parameters world and type to global. And in this case, the hash map that comes here turns into the attributes of the XML. And so the method hello turns into an XML tag hello. The stuff that goes inside becomes the child of this. And so there's a whole language where you can nest more things inside here, and you can write your XML in Ruby. And it's actually kind of nice because notice there's no ending tag. I don't have to do the hello and the slash hello. I know the XML people think they love this, but I always thought it was tedious as heck. And so you can write your XML in Ruby in this way instead of having to know the other syntax. The other advantage is in XML syntax you have to remember how to escape certain things, and the rules are different than in your main programming language. So all you have to only know Ruby, and it generates this thing. But it's a poster child for this very open-ended nature, because hello was just this one tag that I invented. It could be any tag, right? There's not a finite number of tags. That's why I say it's not just HTML. So for an HTML builder, you could simply supply a fixed set of methods, one for each HTML tag. But if you want to do an XML builder, it's completely open-ended, and so something like this would be done with method missing. Now, you don't want to do it unless you have to, because it's very hard to debug. When everything gets routed through method missing, and you misspell something, for example, and you mess up something, it's just a pain. So it's kind of the last-ditch solution and not the first plan of attack. So let's see some of the more controlled things that we can do between somewhere between the total chaos of method missing and the situation in Java or Scala where you can't do anything in runtime. So when you say class.new, you get a new class with no name that you then can do stuff to. You use object const set to give it a name. So here I'm making a new class that so far is anonymous. I give it a name, and now all of a sudden it's called city. So I can dynamically make a new class. And then I can add some fields to it with this after accessor method. You've seen this method. This method was used in two days ago, 2 lectures ago, to add accessors to any old class. And so I can invoke it on this class that I've just dynamically created. And I say I want to have an attribute called name. I want to have one that's called country. Except that's not quite true. It's a private method, so you can't do this out in open code. So what I have to do is I have to put this code into some superclass, and then it'll work. So here's the workaround for that. So I say my base class. Inside here, I call, what do I say? Make fields. Oh, this is my method. This is the method that I'm going to invent. So make fields is the method that I'm inventing. It calls after accessor on this. There's a bit of funkiness going on with fields and the star fields. And that is that fields here is going to take an array, and after accessor wants to take var args, and this turns one thing into the other. I'm fuzzy about the details here myself, but trust me, it'll work. Until it doesn't, and then one has to actually read the spec. This is the general problem that all these languages have. Whenever you have a variable argument list versus you have an array, you have to always translate one and the others. Java and Scala have the same issue. Yeah? Because I'm defining it because I'm not allowed to call after accessor. It's a private method. But I can define it in a superclass, then I can extend that superclass.
I can you just say define make fields instead of self
It's this thing is a private method of the class. And so I can call it inside here because inside here I'm operating on a class object. Maybe I shouldn't. Maybe it's not private. Maybe it's protected. So I'm putting it in here, and that's just a technicality because of,
the class which is inherited only can use this method.
I have no clue what the rules are in Ruby.
So
Yeah.
who defines class? So what is class.new?
Okay, this is a standard method that gives me a new class. You want a new class? You call class.new. You get a new class.
Just the template class?
It's just like a primordial class that doesn't get to very much.
So, but that class has APPR underscore accessor method, right?
Sure, because it's a new object of class, and the class has after accessor.
Okay, so class.new creates a class which has accessor method
Yes.
is defined inside.
That's right. But it's a method that is private in some sense that I don't really know because I don't exactly know the Ruby system for what's private.
Okay.
And so when I just try to call it like on the interpreter level or inside some other method, it won't let me do it. So maybe it's protected.
Okay.
So for some reason they're protecting it with some privacy control. I mean, every object-oriented language has different privacy settings, just like Java, private, protected, public, package. And Ruby has a similar set of rules.
An object is also a class.
No.
Object.const set. The second set.
Oh yeah, this is not an object. This is not an object. It's the class object. There's a class called object, just like in Java.
Yeah.
It has a static method called const set.
Yeah.
That I can use. Const set takes 2 parameters, a string and a class object.
So it creates a class.
No, the class has been created. Here's the class. Here's the class.
It just gives
Okay,
you
so
the
it's creating an instance of a class.
No, this here the instance is already here. When I call class.new, I get a new class.
So what is city class?
Now this class here has no name.
Yeah. So
That's kind of sad. It's a class with no name,
Okay.
which makes it tough to like instantiate it.
Okay.
And so to give it a name, I have to call const set.
Okay. So
Const set is a general mechanism that Ruby uses for 10 unrelated purposes, and so one of them is to give a name to a class.
So now the name of my class is city.
Yes.
Right. So
Now I could say city.new.
Okay.
When I say city.new, I'll get a new object of class city, which so far has no methods or fields or anything.
Okay, the instance of city is class KLSS that you're trying to access in the so let's try adding some fields.
Okay, this thing here is the class that I've created and then I've named city. This one here, right?
Yeah.
And so now this class that I've just created and now named city, now I want it to have some fields.
Okay, so the fields name and country will be added to class city.
Yes?
Okay.
Except it doesn't work because of some privacy
Right.
issue. Okay? So that's what I want to do. So I want to make a class, give it, all dynamically, want to make a class, give it a name, and then add attributes to it. Now why do I want to do it? Because that's exactly what Active Record does. Active Record says, oh, there's a database table called city. It has columns, name, and country. And it then needs to dynamically create this class that the world has never seen before. Right? In Java, what you would have to do is you would have to generate Java code and then compile it. In Ruby, you don't have to compile anything because it's all dynamic. You can create these things on the fly. Yeah?
So why would you create on the fly? What's a good example for that?
Like in Active Record. So Rails starts rolling along, and you say, oh, by the way, there is this, have a look at this database. And then Active Record says, oh, there is this column, and there's this table in the database called, well, country. And then it does it on the fly. You can actually, the way we've done it is we've written some code to do all that migration stuff. You can skip that. You can just give it the name of the database, and it'll inspect the whole thing. You could also envision if you're parsing XML, maybe you want to have a class for every XML tag, and that would also be completely dynamic.
So would you come back and write the actual class, or would you just
No.
leave it as dynamic? the whole
It's
time?
dynamic. There's no point in writing the class; it's there.
Right, but I mean, because Rails generates it so easily with
Well, there's no compilation step involved. So you're saying at runtime you feel the need to generate a class, and there you have it. And so that's a capability that is potentially interesting, and that is actually being used by these things. And so the question that I want to analyze is what goes on. How does it? What does this language do that other languages don't do? And so for whatever reason, it feels that it's interesting to do these classes dynamically. So, but then it's a little bit technically complex that now you have to come up with some base class. And that's actually kind of the same thing you've seen active record.base. And that is the same home for some base magic. So here I've overcome this by putting this method in here that just calls this other private method. And now I can go to town. So over here I'm making a new class, and I give fields to it. It doesn't yet have a name, does it? No, whatever. Who says it has to? It doesn't have to have a name because I have an object of it. I can call new on that object. Yeah, who needs a name?
So what's happening in the third stage?
Okay, so this is an object of class.
Sorry?
When you call new, it makes an object of itself.
Okay.
So now makes an object of what class? Of a class with these two fields. We haven't added any methods, so all this class has is two fields. We now make an object of some class that sadly has no name, poor thing, has no methods, but it does have two fields.
So both class and X will have the fields.
No, class has no fields.
After you make fields.
Oh, I see. This make fields calls add or accessor, which is a recipe that says if any objects of you will ever be created, those objects will have these fields. So the class itself has no fields. It probably has some class. The class itself has some fields where it remembers these lists of attributes. But we're not adding any fields, right? Over here, we're not adding either in base nor here where we're making a new one. We're not supplying any new fields, but we are supplying instructions to endow every object with fields. So now you can see that this is a genuine field because I can assign something to it. Whereas if I now were to say x.foo equals Ho Chi Minh City, it wouldn't work. It would say I don't have a foo. All right. Well, we want to create new methods too, of course. So over here we have this class, and so now we're going to define. So when we make these fields here, I want to have methods that do initialization and that let me set the variables. These are accessors so far. And what if I also want them to be, what if I also want to have an initialization method that initializes with a list of values? So now one has to suffer through a bit of syntax here. So star values is a variable argument list of values. And now I go through, for each of the fields, this each with index is runs through fields, and it gives me f, the first one with index 0, then the second one with index 1, and so on, and that's so that I can pick out the right value. Now, instance variable set is another method that's part of the meta library. Now, I'm constructing the name of the instant variable by add plus the name of the field, and now I can set it with this constructor. What I've just done here is I've defined a constructor. Maybe I should just show how to use it. So this thing here defines a constructor that takes, in this case, a name and a country, and it sets the name to the instance variable of the country to the, yeah?
The define method that takes a colon initialized argument, that's the same as the def initialize?
No, this thing here produces this method. This is the code to produce dynamically this method.
Okay. So you don't, like, for example, want us to write def initialize? Instead, you want.
Well, it's nicer if you don't have to do it. So you put this in the superclass, in the base, and when you extend this base class, your class automatically has an initialize method. So, and where does it come? I've put this into make fields. So if you look back here, yeah, I call make fields. I give it an array of fields. And when make fields does its thing, not only does it make the fields, which it does here, but it also makes a constructor.
The constructor for
The constructor for this class that initializes, that does this trivial initialization. The same constructor that you get in Eclipse when you say make a constructor for each field. Like in just about every Java class that you ever write has this trivial constructor, right? That where it has a parameter for every field, and then you assign them all. You say this dot A equals A, this dot B equals B, and so on. And it's a really boring constructor to write. And Eclipse will in fact write it for you. There's a canned refactoring for it. But here, one can write generic code that makes this constructor.
So suppose you have using that active reference, when it picks up posts field,
Yes?
then it creates, if it
Yes.
extends the base class, and it does right?
Yes, and in fact you've noticed that because in that when you made a post in the console, you didn't have to write the constructor that allowed you to write the post. You simply extended active record base, and that constructor was supplied to you.
So when you say post.new,
Right.
so the new is.
Well, the new calls initialize. Yeah.
The define underscore method is just a function, is a method to create constructor?
It's a method to define any old methods. So if we look at the syntax of it, it takes the name of the method, and then it takes as a block the code of the method.
You could create a lot of constructor using just that method.
Yeah, or other methods too. I could create like a toString method. I would say define method to S, that's how they call it in Ruby, and then I would have to come up with what's the logic to create the string.
So every time you have to write that method to create a string.
No. If I want this extraordinary service of having a free constructor per class, then I have to write these 3 lines of code. If I want the service of having a free to string per class, then I would have to write a different 3 lines of code. If I want to have a clone per class, I would have to do that. Maybe 10 lines of code, because cloning is a little harder. But so I can supply these automatic methods as they make sense for my problem domain.
So when active record is extending base class, does it define that it needs to have these methods?
If you look at the source code for active record base, it has similar magic in here, just more complicated.
So every say action active something else will have its own base.
That's correct. So whoever wants to do their own set of magic, they would have to create some machinery here. Now, of course, active record base does more things to, like, write a record out into a database table. Like when you say save or whatever it was, it has to actually go and write the SQL code to put it in there, and that also is dynamically generated. So it'll produce a whole bunch of methods. Here, I just want to show the simplest possible stuff. But it is amazing if you think about it. There's nothing like that in Java. How would you do this in Java to say, well, I'm going to build up a class. I don't yet know what fields it has, but I'll tell you later. And by the way, when I tell you, also make a constructor. You can't do it in Java. Eclipse can do it in source, and then you'd have to compile that source. But you can't do it in a running program. So here this all happens in a running program. So it really modifies itself. All right. So now we're going to put this to use in a simple situation. So let's say that I want to that I have a comma-separated value file, kind of like a database file, but I'm just using plain ASCII so that we don't have all of the database stuff in there. The first row is a comma-separated list of column names, name and country. And then all the other rows are data entries, data elements. And so what I want is, I want to have now a class CSV base, comma-separated values base, that when someone extends it, then I want to read the first row of a CSV file, and the name of that file is by convention over configuration. It's by convention going to be the name of the class followed by CSV. It's going to load that file, it's going to read the first row, and then it's going to make a field for each of the elements that it finds. That's what I want to do. Now, when you do inheritance, here you would say class and then the name of the class you see, and then you extend active record base. In this case, I'm going to do CSV base. Then as you do the inheritance, the superclass gets notified, and superclass gets told, hey, someone is about to inherit from you. And this is the method that gets called. So in the superclass, I'm putting this method. This method will get called whenever the less than name of the superclass happens. And so then I can put an arbitrary code in there to do whatever that subclass might want to have. So that's a very powerful thing. Again, there's no analog in Java. How would you do this in Java? To say, call me whenever someone extends me. There's no one to call yet, because the extension happens at compile time in Java. And this stuff happens at runtime. All right. So there's more that we're not all going to see. You can turn functionality into a module that can be mixed into any class, even those that already have superclasses. So right now we've extended CVS base, but what if I already had an existing superclass? You can overcome that. You can augment methods, so you can add calls before and after a method call. And that's a nice, for example, if you want to do logging, you can take an existing method, say to a string or something, or maybe it's boring, but say save. And then you can say, whenever save gets called, I also want you to insert this little logging call. Maybe you want to do it before and after to make sure that the database didn't act up in between. You can also generate arbitrary code on the fly and then have it interpreted. That again is a very brute force method of doing stuff. And with all of these things, people come up with really very malleable and interesting ways of bending Ruby into shape. And if you had some kind of a programming problem where you wanted this extreme flexibility, you'd be much better off trying to do it with something like Ruby than with Java. Because with Java, your tools are just so very limited. Anything you can do with Java in terms of code generation means you have to write Java code and then compile it. And so here you don't have any of that. So we're going to do this in this lab, and we're going to do the CSV thing. So here's how you read something from it, and so we're making a new file with a given file name. We call gets. I don't remember what chunk does.
It takes on the end or the spaces of the
Oh, maybe it's like trim. Yeah. Okay. Split is pretty obvious. You get an array of things, and then you do something with that. And then what are we doing with each line? Oh, right now we're just printing it here. That's just for you to see. So, and so here we're going to start out with using method missing from this. So, you just have to do it. There's no point. There's nothing that I can do to translate. So let's just go ahead and do this. I'm going to go do it with you because I forgot how to do some of these things. Then we're going to have a quick look at the XML builder, and then we're going to go to this what we had in the last slides. And of course, all of this is builds up for what you need to do in the homework, where you need to practice more of these things. So the biggest challenge that we're going to have is how can we use our puny Ruby knowledge to get past the syntax errors. So if you have some syntax issue or something, just raise your hand, and I'll see whether I can